So how do we use for loops? Now we have a brief idea of how to write them, we have an understanding of how they work, but now what we're going to be looking at is how to use for loops. So we just have a brief demonstration, and our demonstration is now to actually start off with what we initially promised, that we're going to be drawing a program that takes an arbitrarily regular n polygon where we input the integer n. So I want any integer that I can input, and it should basically be giving me a regular polygon with that input. So in this code, as you can see, we've pre-entered your initial commands of labeling the turtle, as well as we've entered the command through which it ends turtle.done to just make life simpler for us. But what we're going to be doing now is we're going to be asking the user to input the number. Please enter a number of your choice. The idea of colon is just for some hygiene, and we kind of store it in the value of n, and now we write for I in range 0 to n. So this runs from 0 to n minus 1, which is n times ninja dot forward is 50. We just keep it low enough so that it fits into the screen, because if I write 100 and you write a large n, then it kind of increases. And ninja dot left is 360 divided by n. And as you can see here, we run the code. So here it's asking us to enter a number of our choice, and let's say I enter my number as 20. It makes it a 20-sided polygon that you can see here. Right? Now let's just try and play around with this again. We run this code again. It asks us to enter a number of our choice, and let's say I keep it 13. So here we have a 13-sided polygon. Now this code takes any n and draws a polygon, which does not need to for us to actually repeat a program for a new polygon that we want. Now we want to use another code, and in this code we want to encounter how to use multiple for statements in the same loop. Rather, we want to actually write these multiple loops which are generated by for, and such that each loop is basically entangled into another, and what we call nested loops. So the problem here is to draw an equilateral triangle that's like subdivided into 4 parts. So how does that look? It looks a bit like this. So you have this equilateral triangle, and each equilateral triangle, you can see it can be written in 4 different parts, and we want to use for loops to actually do this. You have to draw this particular piece of code. What we're going to be doing is we're going to be using 2 for loops. So the first for loop is for I in range 0 to 3. So we got 3 sides, so it has to run through 0, 1 and 2. So first we ask it to draw the triangle. So ninja dot forward, let's put it at 90, and ninja dot left 60. And this is essentially what we need to just draw our equilateral triangle. But what we additionally want is, at each of the vertices, we wanted to draw another smaller equilateral triangle such that it subdivides the triangle. So what we do is for j in range 0 to 3, and just pardon my mistake, it should be 120, because 360 divided by 3 is 120. That's the angle we should be considering here. Ninja dot forward 45, which is exactly half of 90, and ninja dot left 120. And we run the code. As you can see, it completes the equilateral triangle as we want it. So this is how we would actually draw our equilateral triangle that's subdivided into 4 further equilateral triangles. And you can repeat this process and try and basically repeat it for smaller and smaller. And you can actually see in this code how you can actually write one for command within another for command. And the important thing here to notice is when you write another for command, you again have to indent the body further to the right of your for command, and the for command that you're nesting within the larger for command has to be intended with the body of the previous for command. So that's how you would basically write your for command, with multiple for commands in the same program. And the next demonstration is, let's say I have a drunk person, and now this drunk person can walk right, left, straight, or behind. And at each time, let's assume they make an angle like which is perfectly 90 degrees. They can walk one step to the front, one step to back, one step to the left, and one step to the right. And each time we assume the step size to be the same. And now I want to basically simulate the walk of a drunk person for 16 steps. So now what happens when a drunk person walks is that you don't know whether this drunk person is going to go right or left or straight or behind. In fact, the drunk person themselves need not necessarily know where they're going next. So what we use here is we use a for loops along with the random functions that we previously encountered and conditionals to simulate this walk of a drunk person for 16 steps. So in this example, we basically have to kind of use a random number generator. So to first get a random number generator, we first try to import a random int from random. So from random import rand int, and then we start a for command for I in range 0 to 16, or maybe we can just write it as n and just initialize our n to be 16. We first generate a random number between 0 and 3, and so x can take the value from 0 to 3, and we put a few conditions. That is, for instance, if x is equal to 0, then ninja dot forward 50. If x is equal to 1, ninja dot back 50. Else if, let's say, it takes the value 2, then we ask, so there is an alignment issue here, so we're just going to correct that. Ninja takes a right turn of 90 degrees and ninja goes ahead by 50. Else ninja takes a left turn of 90 degrees, and then ninja moves forward by 90 degrees. Okay, this is the code that we've written so far, and let's run this. And as you can see here, this is perhaps how the drunk person would have walked. And now let's kind of repeat this code again to see how it would have walked if it was another drunk person, or if the drunk person was walking at another period of time. So as you can see here in 16 steps, the moves here are very different because there is something very inherently random about the way the drunk person walks. And now this phenomenon that you've seen of this drunk person walking is actually what is called as a random walk. It is a concept that's of utmost importance in statistical physics, where you're trying to understand how particles move in a gas. It's also a concept that has wide applications in people like biology, where you're trying to understand movements of particles within cells, and you're also trying to understand, let's say, Brownian motion. It's also a phenomena that people use widely in finance to understand how stock markets move. So it's a phenomena that's of wide application and importance. So what we've primarily seen here is basically how do you use conditionals and random numbers along with loops, or how you can actually also enclose conditionals within loops. So what you saw during the course of it is using for loops. We use nested for loops, that's to generate your equilateral triangles, which is broken up into 4, and we also use loops in combinations with conditionals. So here's a bit of a trivia. So with loops, what we have seen is something that's so-called Turing complete. That is, anything that can be done by a programming language can be done using the toolkit that you've developed so far. Now, basically, this is the bare minimal toolkit that you have so far. It's not the ideal in the sense that there are many things that are slightly painful to do with this, but with this that you can do everything that can be done in the Python programming language or in any programming language that you can do something, you can actually do it using the toolkit you've developed so far in this course. Thank you and stay safe. And we have exercises, so please have a look at these exercises and hope you have a great week ahead.